Hello, Internet, and welcome to the Braindrizzle podcast. I'm here with my co-host, as always, Jack, and today we have two guests from the Cosmic Web channel, Ida and Steve. Hello, guys.
Hi.
Hey, how's it going?
It's going good. It's really awesome to have you guys on the podcast. For our audience who might not know, why don't you tell us a bit about your channel?
So our channel is called The Cosmic Web, and so far we have 4 videos posted, and they're all about dark matter and dark energy. And it's a very basic introduction. And in the writing of this video, we had high school students in mind. Hopefully in the future, we plan on expanding to other topics of cosmology, of physics, and a lot of other interesting things.
Steve, what's sort of your role in the video production?
So I am an astrophysicist, and so I am trying to keep Ada honest, but I try to let the high school students and Ada do a lot of the writing and the investigation of the material for this. I do a lot of the video editing for the channel.
So you're saying that not only is it targeted to high school students, but they actually help in the writing?
Yes, we have several high school students and some other undergrads that have taken roles in doing the writing and investigating the right level of the material for high school classes.
Oh, that's really interesting getting high school students involved like that. What sort of gave you the idea to not only target to them, but involve them, and sort of how did you go about doing that?
So it was a little bit backwards, and in fact, it was Ada's idea. So I have been visiting high schools and trying to, in a 45-minute presentation, explain what I do. And Ada, who was working with me, visited one time and gave a presentation. And as we were leaving, I said, there's just not enough time to do this. And Ada said, well, why don't we make a series of 5-minute videos? And I told her that was the best idea she'd ever had. And and so we started on this, and we got the high school students involved, and it's been a lot of fun.
I imagine so.
Yeah, it definitely has. And on my side, I think I've been interested in starting a channel for a while. I think I wouldn't have started this entire project had it not been for Steve. And I really like the potential that YouTube has to communicate ideas so fast. And then it's so empowering to think that you could be able to summarize very difficult concepts, not only on writing, but on such an interactive thing like a video, in which you can add images and, there's a tone of voice, so not only a script that you can read off of. So that's one of the aspects that fascinates me.
Now, you mentioned that Ida, you and Steve gave presentations and other things. So what is your sort of main work outside of making the videos?
I'm an undergraduate and I study applied mathematics and physics. And I joined Steve's group of research, and our work is on dark energy.
Oh, so it's pretty cutting-edge stuff you're working on.
I would say so, yeah. It's really exciting.
I'm kind of a noob on the whole college scene. Is it normal for undergraduates to get involved in research, or is that are you just that cool?
I think it's becoming more and more predominant, and definitely Steve can give you more feedback on this, given that he has been a researcher for 20 years and he has had students for pretty much the same time.
So, Steve, tell me about this. What do you think is causing this to become more of the norm, if it is becoming more of the norm? And what do you think about this trend? Good thing, bad thing? How do you feel researchers need to adapt to having more undergraduates and therefore less experienced individuals involved in research roles, actually doing science?
It's been pretty common for undergraduates to do summer research, and there have been programs set up for my entire career, 20 years, that will allow them to participate, say, in the summer. It's a fairly recent development that it's become kind of a year-round project, especially at the universities, and a lot of effort getting into graduate schools is extremely competitive, and having your name on a couple of publications and having that research experience on your resume helps a lot. And so advisors have made much more effort recently to get their students involved in their research.
No, I'm just curious, if you don't mind me asking, what university are you two based in?
So I'm at Argonne National Lab outside Chicago.
And I attend Illinois Institute of Technology, which is also in Chicago.
Cool.
Ooh, Windy City.
This question is for both of you. What drew you to cosmology? Because even within physics, there's a lot of subcategories you could go into.
Once again, Steve has a much wider background on this. But for me, I think I've been passionate about astrophysics since I was probably 5 years old. Really, like before I started elementary school, I've always been looking for journals for the general public to learn more about astrophysics in particular. And I started university with the goal of eventually doing research in something astrophysics related. So I think it has been part of my life basically forever.
See, when I was 5, I thought it was impressive that I memorized dinosaur names. So you just blew me out of the water. Steve, even if you have a broader background, what drew you into physics, I guess, as opposed to chemistry or biology or pure mathematics?
I started as a particle physicist. I was intrigued by the inside of the atom, and so I worked on that for about 15 years. But then I guess several things happened. One is the whole puzzle, dark matter and dark energy, became so incredibly interesting that a number of particle physicists have made the jump from particle physics to cosmology, and it's a growing trend. This is something that I did about 5 years ago.
So when you make the jump from particle physicist to cosmology, does that mean that you have to switch teams, so to speak, like your softball league? Do you have to go play for the other team?
Yes.
Do you guys have softball leagues? And if so...
Exactly. They kick you off the team. It's actually worse than that. It's like going back to grad school, and it may be even undergrad, because it's really a different world and with a different language. So in many ways, it's exciting to almost start your career over and work on something very different.
Did you cry when you had to shave off your beard and throw away your Hawaiian shirts?
Well, actually, the astronomers spend more time in Hawaii than the particle physicists, so maybe that's part of the attraction.
Now, thinking about it, that's probably like the biggest jump in science you could make. You're literally going from the subatomic to the largest scale in the universe that we study.
Exactly.
Well, yeah, at the same time, there's so many similarities, and in order to truly understand the big scale structure of the universe, if you don't know the elementary components, then you don't have really a big chance to really deeply understand what's going on, apart from just describing how the whole system is evolving. I think it's important to have that particle physics background.
In the study of dark matter in particular, you are trying to figure out, in essence, part of it is what kind of particle is it?
Exactly. And it would be an addition to the model that we already have of baryons.
Not only that, Ada is very accurate because there's many other connections. For example, the elusive particle called the neutrino, which passes through the Earth like it's not even there. The number of neutrinos can change how the universe evolves in the early universe. So there are many other connections between particle physics and cosmology.
If you don't mind me asking, has there been any sort of interesting results from your research or other research in the field that has been new and interesting, or is it just a slow, steady progression toward understanding?
In cosmology, I would say the discovery of dark energy is only about 12 or 13 years old. And so that's pretty recent in terms of scientific developments, where things in these fields don't change very quickly, at least in terms of the big picture. I would say since I really started at this 5 or 6 years ago, we've been working on a new camera called the Dark Energy Survey camera, and that is just now being commissioned. So actually the science is just now starting.
For that camera, are you going to engineer, or are you and the other dark matter researchers helping design that camera?
It's a collaboration. The scientists design the specifications, and the engineers have to take care of the hardware.
How soon before there's an iPhone app that allows you to take pictures of dark matter with your iPhone?
Let me think about this. I would say never For the detection of dark matter, you can use other indirect methods or direct methods. With the direct methods, you have hypotheses of what the particle could actually look like, and possibly in the future, there are a lot of researchers, for example, in CERN, that are trying to use other supersymmetry. They're trying to discover all of these new theoretical particles that might justify the existence of dark matter. But when it comes to indirect dark matter, well, everybody can pretty much create an app, right? For indirect detection, there are already a lot of researchers that are making maps of where dark matter should be based on observations of various gravitational attractions. It would be easy to put that in a phone and just say, here is a map of dark matter in various areas that have been observed, around the sky. But for direct dark matter, like actually knowing look like, that's pretty much impossible. That's even impossible for electrons and protons and other particles that we are certain about.
So this new camera you're working on, what is the basis? Is it indirect in looking at how light is distorted by the mass, or is it looking at some other spectra on the wavelength?
All right. For that, I invite anybody that is listening to watch our video on the difference between dark matter and dark energy, because our research is on dark energy. So dark energy is basically the substance that is believed is causing the universe to expand faster in this late times. Okay, so not in the early times, but for the past 4 billion years or so. And dark matter is extra mass in the universe that possibly doesn't interact electromagnetically, so doesn't emit light, but it does interact gravitationally with other bodies. So they're two separate concepts. And our research is focused on dark energy.
That's really cool. I had a question about dark energy, actually. So eventually, the universe will be expanded so much and be expanding so fast that we or someone in our galaxy wouldn't be able to visually see other galaxies, correct? I mean, eventually it would get so stretched out that it would bleed into the infrared.
You could expand to a rate that basically the universe is stretching faster than the speed of light. And we know that the speed of light in the vacuum is a constant due to special relativity onwards. That's one of the postulates that we have in physics. Yes, that's a state that could be reached. But at the same time, locally, for example, our group of galaxies are gravitationally bounded. So until these galaxies will have fuel for their own stars, there will always be something visible in the universe. Some objects that are too far away won't be accessible anymore.
I have a sci-fi brain, so I always think it'd be interesting, like a sci-fi that takes place way in the future and a civilization develops and doesn't know there are other galaxies.
That'd be pretty cool. Also pretty sad because they wouldn't be able to know of everything else that is over there.
But until they invent like infrared and radio telescopes.
There are infrared and radio telescopes.
I was thinking about in the sci-fi, the civilization would develop a way of detecting other forms of light. Anyways.
Okay, I got it.
How often do you guys get questions regarding sci-fi concepts from high schoolers?
Basically, the majority of the questions are somehow sci-fi related or connected to parallel universes and are they aliens? I think that's one of the most common questions.
Well, these are high school students that have volunteered to write about physics, so that's sort of not surprising.
Yeah.
So, you mentioned that you want to branch out into other concepts. Would you mind giving us a little sneak peek of what other video ideas you have in mind?
Oh, sure. All right. So right now I've been working on a script about this thing that is called FLRW metric, which has a really cool name, which is actually an acronym for all the scientists involved in its formulation. But basically, I would like eventually to reach all the theoretical background to describe the work that we're doing in our research. We hope to explain general relativity in a way that is accessible to high school students, but hoping not to have much loss to the concept and the beauty of the mathematics itself. Because this thing that has this very confusing name that probably not many people have heard about, that is FLRW metric, actually is just a generalization of Pythagorean's theorem, for example. But this very structure is able to describe the entire evolution of the universe. So with a set of equations that can fit very well in a screen, have 10 variables or so, well, actually more than that, but you can fit them in in a screen and you're able to understand them. And this is all that you need to describe the entire universe. I get really excited every time I think about this because we reached a level of knowledge in our society that by abstract concepts, you start from postulates and you put various constraints, and at the end, you manage to do what? To describe the entire evolution of the universe. And that is just phenomenal. When it comes to other videos, I would also like to talk about an introduction to quantum mechanics. Eventually, as soon as we finish giving a broad introduction on cosmology, which is going to take a pretty long time. I think right now we have how many videos? Probably 30 videos in our queue. And I don't know when we're going to get to the point of writing them all, but that would be the plan. We have a lot of ideas.
I'll take that opportunity to interject. If you're listening to this podcast on YouTube, there'll be a link in the video description to their channel, so I recommend you go subscribe and support them to keep up with all the cosmology and physics videos. And if you're listening on iTunes, go to youtube.com/thecosmicweb and subscribe.
Thank you.
No problem. Now, Ida, you actually used to write for Brainstorm.
Yes, I did.
And since you started doing your own videos, I've done far few physics stories.
I'm sorry about this.
No, it's okay.
Yeah.
So in communicating any science, there is that balance of not oversimplifying it, but making it accessible. How do you find you strike that balance?
Actually, I try to picture just myself how I used to think about things right before I learned them, or I definitely do try to explain it to people that are close to me and see what are the things that they struggle understanding and so on. I think that's one of the major contributions of our high school students. So I say something and they maybe do not react in the way that I was expecting. And I say, I think it's really cool. So let me phrase it in another way and hopefully I'll get that reaction that I want out of you.
So let me see if I understand this correctly. The starting point for conveying complicated information is first self-awareness, and then the exploration, and then experience, direct experience with other people's reactions to giving information.
I definitely believe that. Another essential thing is for me to really and deeply understand the concept, because I don't think I'd be able to explain something unless I don't have all of my own questions answered. Otherwise, I might be able to phrase it in such a way, especially when we write and when we record unscripted, I can phrase it in such a way that I myself can ask questions, and this happened in the past. So until you reach that point where you know something to the level that all of your questions are answered, you cannot really explain that topic, or at least that's how I work. I don't know how other people work.
If your high schoolers are ever busy and you want to see if the script is good, just send it to me, because I do not know physics very well. So if I can understand that you're good.
All right, thank you.
No problem. So, Steve, I understand that you are sort of a supervisor, but you mainly edit the videos. How have you found that?
Oh, that's a lot of fun. As we go on, we've become a little more liberal with the fancy annotations, and we're having more fun with it. And the routine editing is going a lot faster, and so yeah, it's a blast.
That's cool. So, do you have experience with editing, or did you just jump into it when you started this project?
I've been editing ever since my college-age sons were small, and so I've been at this quite a while.
I see. So I guess once you get through the cosmology, you plan to move on to quantum mechanics, and then is there anything after that, or do you think physics will just be done by that point?
You know, I think inspired by Brainstorm and my youngest son who's going into biochemistry, I think I'm going to quit physics and go into biology next. And
Really?
yeah, so I'm joking.
Steve could never ever quit physics.
Biology is gross.
If you did that, you'd really be all over the place. It's like, okay, particle physics, cosmology, then biology. Just for yucks.
That's right.
Yucks, literally. I almost wonder if maybe you can predict what kind of scientist somebody is prone to being based on what they played with as a kid. Biology students played with garbage pail kids, and they liked things like gack and weird bugs, and that joke where you ask people if they like seafood and then you open your mouth and show them your lunch. Those are the biology kids. Then you get on to physics. They were the ones who basically didn't want to touch anything. If they blew their nose, they had to wash their hands. They always had the big bottle of hand sanitizer in their backpack.
That sounds like a very accurate description, actually. Yeah.
Oh boy. They usually don't have contacts because they just can't stand touching their own eye. They know exactly where their fingers have been, and while it's cleaner than most, it's still not pretty to them.
And the chemistry students, whenever they got Jell-O with whipped cream on top, the first thing that they did was mix it together really hard. I did that.
Yeah. The chemistry kids, you could not leave them alone with the blender, though for a different reason than the engineering students.
Now, sometimes mostly on the podcast, when we don't have a guest, we talk about sort of general science news, and I had a piece of news I wondered if you heard about. Apparently, some researchers discovered what they think is the largest structure in the universe. Do you know much about that?
So I think that's a very large galaxy cluster, I believe.
Sort of. It's a collection of quasars that, according to what they've seen in the statistics, it didn't just happen because the quasars are randomly sprinkled throughout the universe and the universe is just kind of like uniform throughout, but they think that maybe the quasars actually kind of group together, and this thing's like the third the size of the universe. It's like this line of quasars, apparently.
Yeah, apparently it's like a 4 billion light-year filament, and the quasars are meant to be centers of galaxies.
Basically, since Quinn and I watched the video, and you guys are scientists, but a lot of our viewers aren't, they're just nerds, let me try to explain this all kinds of weird. My sister, whenever she gives the cats treats, what she'll do is she'll, take them and actually dump them out a little bit onto the carpet so that they're spread out, so all three cats can get at them and don't necessarily fight over each other's piles, because you put down a pile, all three cats run, there's a cat fight. Spread them out, they go for one, go for the other, they don't necessarily bother each other, right? You can kind of think about that as sort of the distribution of the galaxies, if the biggest, baddest old one was trying to eat them. Anyway, forget about the old ones and kitties, just think about the treats on the ground. They fall on the ground, but you can actually find where some of them are grouped together, just because that's where they landed by chance. Think about those treats as quasars. Let's say that somehow there's some sort of magic force, the treats have little magnets in them that make some of them land closer together, right?
It's always magnets, isn't it?
It's always freaking magnets, man. Fuck, how do they work? Magnets. I mean, for all I know, a magnet could show up inside a cat treats, man. It's crazy. The universe is crazy. It's miracles everywhere. Anywho, if there was some kind of force that made some of the treats fall closer together than they normally would, you'd actually be able to statistically determine that, hey, these treats didn't fall randomly like they're supposed to. They're actually, some of them are grouped together. This is a setup. These treats aren't sitting right on this floor. Basically, that's what they're seeing with the quasars, is when the spaghetti monster dumped the quasars down for his Cthulhu cats, there were some magnets in them.
Yeah.
So
this is basically gravity having action, and the universe isn't perfectly homogeneous, but there is some structure that you can discern.
correct. They use similar wording in the video that we saw that was explaining this concept. Good job.
We found a video on 60 Symbols channel. The people that found the structure that's 4 billion light years long say that it sort of challenges a notion that the universe is homogeneous at incredibly large scales. So I was just wanting to get your opinion. Do you think that a structure this big changes anything, or is it just sort of meh?
I'm very curious to hear Steve's opinion. Actually, that video, now that I remember, is on my Watch Later playlist. So as soon as I have time, probably right after this podcast, I'm going to watch that video. But I don't really see how that could disprove the homogeneity of the universe, given that we have the cosmic microwave background, which is basically the radiation from over 13 billion years ago that has been stretched from the gamma and higher wavelengths to the microwave wavelengths. And if you observe this, there are many surveys that have been done on the CMB, and they all show that you see this homogeneity in the entire universe, and the fluctuations and the perturbations are only on the order of microkelvins. Because kelvins, one way in cosmology to express the energy of the universe, so with an analogy with the temperature. So I'm really looking forward to watch this video. But at the same time, the cosmic microwave background does have some fluctuations. So it is not true that the universe is homogeneous at every possible scale. In fact, that is definitely not true at the local scale, because otherwise we wouldn't have any structure, we wouldn't have any galaxies. Hopefully I'll be able to better answer that question as soon as I watch the video and possibly read the related paper. What is Steve's opinion on this?
So I'm now reading the article
All right.
while you were talking. There's an important piece of information missing. I'm going to have a hard time judging it. This article doesn't actually say how far away this cluster of quasars is. I have to say that you have stumped us. Congratulations. It looks like this announcement was about 3 weeks ago, and I had not heard of it. And so I'm very curious to learn more about it.
Disprove them. Just be like, you're wrong. And come up with a better title. Just title your paper that disproves these guys in Latin. And the Latin translation should be magnets. How do they work?
Right.
Because, is there actually a rule saying that the title of the paper has to pertain to what you're talking about? I know that's helpful, but is that actually a rule? I don't know.
Or somehow get cats into the title. Isn't that what you want? Yeah.
Something that'll lead it back to us so that real scientist types find our show and we can get more guests is what I want to happen.
We have Steve, who is a real scientist type.
Do you have any friends, Steve?
Yay!
No, that's part of the requirement.
Oh my god, really?
Damn.
Lame. Well, your next softball meeting, man, ask those guys, unless they're kind of sketched out by you. You did come from the other side of the spectrum.
That's right.
Alright, here comes Benedict Idler. Hey, Steve! How's it going?
There you go.
I guess all the particle physicists are busy partying at CERN, and then all the cosmologists are left in their telescopes in their labs, just sort of working away.
Their tiny party hats and their, in their Walmart cake, while the CERN people are out in their limos being rock stars and whatnot.
Yes. Now, I have to say, a number of my old colleagues were involved with the Higgs boson discovery, and after that announcement, they came to my office and said, I missed out on all the fun. So, they're being very mean.
Well, don't worry. In a few years, when you guys actually figure out what the hell dark energy is, then you'll be laughing.
That's right.
Exactly. Take the words off my mouth, Q-Dragon.
In sort of that realm, is there a big project like CERN? There are a few experimental dark matter detectors. So, is that a big thing, or is it?
I think the Dark Energy Survey is the next big thing. Yeah, the projects that we're involved in right now. It will complete the data collection in about 5 to 6 years. So that's probably the time when you'll hear a lot about it, a lot more.
I see. And then the media will misrepresent it, and then we'll have to cover it correctly.
That's right.
Exactly. We're counting on you.
Yeah.
Okay, no pressure.
So basically, when you guys actually get around to putting this out there, we will know by the fact that the blogosphere will be talking about astrophysicists trying to build a bizarro Neanderthal baby clone in space.
That's your clue, right? Okay.
That's the clue. It's just like, this is your sign. It's going down. The Twitters are all a blogger, or the blogs are all a Twitter, however you want to put that. Either way, they're putting their foots in their mouths because they're going to get something wrong.
Maybe by then, we'll be running the science media.
Hopefully. You know, we can become the science media moguls and...
Just 6 years, right?
Mm-hmm.
Yeah, we can be supervillains by then. Yeah, we can control the airwaves.
Yeah.
Um,
You're just referring there to episode 2, right? Of Brain.
hey, you guys watch us!
Oh my gosh! Yay!
You watch more than 6 minutes. Because apparently that's
It was at the end,
6 minutes is the average view length.
is it?
Yeah, we're trying to go for a little bit of continuity here. Guys, if you didn't get the joke, watch the back episodes, man. I mean, it's you gotten this far into the podcast, therefore you got the time.
Yeah.
Exactly.
Actually,
Face it, man. You're a science nerd. You have the time. Friday night? Yes. Party hard.
yeah.
Also, let's point this out. This episode will be released on the weekend, but we're recording it on Thursday, on Valentine's Day. It's a little bit sad.
I bought myself some Valentine's Day candy right before getting online to do this.
Well, what's wrong with that? Some Valentine's Day is just another day like any other. If you want to celebrate love or anything else that you want, you can celebrate it anytime you want, right?
Yeah.
Spoken like a true science nerd who doesn't have anyone on Valentine's Day.
Well,
Like all of
Wow.
us. Like all of us.
well, who told you that I don't?
You did when you said hi. You shut up.
All right.
I got somebody, but he lives in a different state, and well, this is more important. Kind of, sort of, maybe, yes, no. No, actually, I'm gonna go visit him, and we're gonna do ours next month. So, extenuating circumstances, long-distance relationship, happening mostly over the phone and internet. I think that's actually a step below single when you're, in a long-distance relationship on Valentine's Day.
Well, I don't see it like that. But if you're celebrating it next month, then you can celebrate it for Pi Day.
Ooh!
That's true.
So March 14th instead of February 14th. What's so special about February 14th anyway?
It's Valentine's Day.
February 14th. Yeah, but
Well,
who
yeah.
decided that? I think the church decide that February 14th is dedicated to Saint Valentine. So I don't know. Not so much of importance.
Yeah, well, card companies decided about the whole love motif. I know the whole Cupid thing and the hearts and the Valentines and the chocolates. None of that is canon, man. That's straight up cultural hallmark, and I'm pretty sure there has to be some kind of hoodoo involved. I don't trust it. But I do like candy, and I like it when people try to give me candy. I think I'll go along with it even though it's a capitalist pig fiasco.
All right.
Well, I think we should stop there before this turns into a relationship podcast.
I will paint this city red with the power of Marx, you capitalist pigs. Do not tempt me with your Russell Stover shenanigans.
This degraded very quickly.
Comrades!
This is a record going from like cosmology straight to this.
Cosmology to Karl Marx.
I'm impressed, I must say.
Well, I like to be festive.
Well, that's sort of what we do here on the Braindrizzle. We start very serious and very scientific, and then it's downhill from there.
It's true. It's very true. It's what the viewers want, and guaranteed we're the only podcast who does it that way. The other podcasts, it's not that they just have their shit together. No, it's because we're so great.
They're boring. Let's just go out there and say it.
Yeah, it's true. I mean, there is something to be said for being spontaneous and being forced to be creative, and not actually having a definite plan of action sometimes have its benefits. Let's put it that way.
And with that, I think we'll end. If you're still listening, remember that all the links are in the video description on YouTube, and that their channel is youtube.com/thecosmicweb. Until next week.
Yeah, check them out and press chicks with the fact that you know what dark matter is.